All right, so this is going to be a fun lesson. Basically, we're going to have a pig head fall through the air. Maybe it's made out of ceramic or something, and it's going to smash on the ground. And that smashing is going to generate a bunch of smoke and particles. And the smoke and particles are going to be affected by the pieces flying through the air. They're going to be collided with. And that's going to change their velocities and all that good stuff. So obviously, the first thing we're going to need is the pig head itself. Classic test geometry pig head. And there he is. And you know what? Before you even go a step further, I'm going to save it. In fact, I'm going to save it off of the first failed attempt that I tried to do this. Now we can pretend like it never happened. Great. So there he is. Get rid of this guy. Now the way we're going to fracture this is by scattering a bunch of points on the surface of him, and those points are going to be the center of a bunch of new pieces. So basically we're going to split up this 3D model of the pig head using a bunch of points that are fed into something called Voronoi fracture. Now, Voronoi fracture is not a simulation itself. It's just a mathematical algorithm that basically says for every point, the space around each point that is closest to that point becomes a new cell. Now, that kind of sounds weird saying that out loud, so let me just show you. So these points are clearly being spread around on the surface of this guy. That's not a necessity, but it's definitely a convenient way to start with a bunch of points near your geometry, is just by putting them on the geometry. The Voronoi fracture itself takes the geometry to fracture and points. So there's the points, and we feed it in. And now if I visualize pieces, smash. There it is. That's based, again, off of these positions. Now, if for example, if I change the positions using, let's say, the global seed will, like any random number generator, will move these around. Let me turn this on, maybe it'll be a little easier to see. As I change the seed, it's making them dance around. Now, they're all still on the surface, as you can see. But they're just pseudo-randomly being put in other places on the surface. So we got 20 points, because that's what we asked for. And those 20 points are being fed into here. And you'll notice that as I change the seed, well, the whole fracture changes every time too. Pretty cool. And probably an even better way of viewing the fracture is with the exploded view. And once again, as I change the global seed on here, the whole fracture changes. Pretty wild. I'm going to turn this visualize pieces off. I'm going to leave this over here and come back to this. And we're going to make an interior detail. Interior detail, as you can see, we went from having these new surfaces that were created on the inside. So we have our old surfaces, of course, with the texture on it. The new surfaces are flat. And that's, unfortunately, a byproduct of Voronoi. We can try to mitigate that by adding detail. I'm going to make it much smaller so it kind of matches the outside look. And then we'll just maybe noise it up a little bit. This is using a noisy displacement only on the interior parts. So now we've got that look. And of course, if we just turn this off, it's back to this. And we can just see the noisy interior fracture now. What we're ultimately going to do, we're fracturing this ahead of time because we're not going to rely on a physics simulation to break this apart for us. Most of the time, you fracture it artistically yourself. Maybe you might cluster more points in the area that you know is going to hit the ground first. We're going to talk a lot more about destruction and rigid body stuff later. But for now, suffice to say, we've got about 20 pieces. If you want to select these pieces in the viewport, you'll notice that the primitive selection mode is just selecting one face at a time, and that doesn't really help us. You can click on this guy, and this is new in either Houdini 14 or 15, and it'll let you select by groups. Now, we don't have groups designating these specific things here, but what we do have is this name attribute. And what does the name attribute look like? Well, the name attribute is a primitive attribute that says piece 0, piece 1, 2, blah, 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 blah. Basically, each polygon knows which the chunk that it's attached to, or piece, using the nomenclature here. So the explode is actually using that. That's how it knows what to break this up as. It says piece attribute name. So it's looking and it's saying, well, for every unique one of these strings, and this piece 0 goes for a bunch of polygons, it knows to break that up. Now that same courtesy extends to when we're in this mode. I can go to here, attributes name. Now you can see here's all the pieces. Apparently there's 21 pieces, which is more or less right. And now I can select these pieces. And if I needed to, I could press T and move it out. And now it's a little more like maybe you might be used to in Maya or what have you, where each one of these pieces would have its own name and its own transforms and whatnot. Houdini generally doesn't work that way. As you saw, it's still just one big pile of polygons, one big pile of points. Show all, I had hidden them earlier. But yes, but the name gets it that much closer, and the name is also going to be used by a lot of other tools that work on like a chunky level. So anyway, so now that we have this, I'm going to bring this guy back. I'm going to move him up. I'm going to move the whole thing up. Just so we have him, we can drop him from a greater height. So maybe this is good. And while we're here, I'm just going to rotate him just so he kind of hits the ground at an angle maybe. Maybe that might be more interesting. Also, while we're up here, I'm going to make a camera. Remember, control-click the camera. This is just so we can, I'm going to move it back by clicking on the lock. This is just so we can get back to this later, and we don't have to keep finding like a good angle. So there we go. So this is where our camera will be. And we have our pieces now. And although I don't usually like to do this, let's use, because we're not going to talk about how to really set up a rigid body thing, let's just click RBD glue object from the rigid body shelf. We'll say RBD packed object. I'll explain what this means when you're older. Let's not concern ourselves with it for now. And let's also add a ground plane. And what it's doing, all this is doing is it's building out this whole DOP network. Look at that. Remember we had to build this whole smoke thing last time? Well, this is instead populating it for us. This is not smoke, of course. This is the rigids themselves coming in here in this rigid body object. The ground plane that we just made. The merge, which is saying collide the ground plane with them. It's being solved by the rigid body solver. It has gravity. And the pieces are all glued together until they experience a force strong enough to break them apart. That's just the high level, just so you have a general idea of what it's doing. I'm also going to give it an initial velocity. Maybe we'll say smash down 15 units per second. So bam. So there you go. Pretty cool. Not bad. Everything's colliding with itself. I feel like we could probably make it a little more violent than that. So let's kick it up, maybe 33%. That's pretty good. Cool. Wonderful. Save it. Now we're not going to have the eventual smoke affect the rigids. Like, it's not going to push the rigid bodies around or anything like that. So basically what we have here, that shelf, not only did the shelf set up the auto DOP network, which we're going to rename right now into rigid sim, or I guess rigid sim for the sake of conformity. It also put some nodes in here. And the node that we're interested in is this DOP import. This is basically getting the result of our rigid sim. So you changed the name and I changed it. It's getting the result of it. It's putting it here. And remember when I said that I'm not going to explain what packed stuff is? Well, I'm still not going to. But we need to fetch unpacked to basically get it back to the form that we're used to. And we would do this anyway. So great. I don't know why those pieces are selected. And let's get that off. And we also want to have it, let's actually get some velocities back in from the sim too. That we're gonna want that for sourcing our particles from later. So I just turned on the velocity viewer here. And you can see, look at all that cool hairy velocity we got. See, lots of cool stuff. Important concepts to note. You can see how it looks swirly. That's because we're seeing the per point velocity. We're not seeing one velocity for the whole overall object. As things are rotating around their center of mass, they're moving different directions. This side is moving down while this side is moving up because it's spinning. Something that you know intuitively, but it's still, that will come up because we're going to spawn particles from the surface based on those velocities. So it's important to know why some are going to be getting thrown down and some are getting thrown up. Great. So guess what I was starting to say before I cut myself off, is that this is just going to be the rigid sim. We're not going to have the smoke happen in this sim. We're going to make another sim to do that. So what that lets us do is it lets us run it, do whatever we need to do in the rigid sim as a separate entity, and then save it. And let's do that here. We'll say save the disk. And it's going to run through it pretty fast because, there's only 20 pieces here, and they are all colliding with each other, but rigid SolidWorks has come a long way. So now we can basically simulate 20 pieces as fast as we can write that to disk. Cool. Load the disk, or load from disk rather, and now we just have it. Now we don't have to wait for the simulation anymore. And I'll just say rigids, and we've got that.